Hello everyone, welcome back to my YouTube channel. I am Kavya. Currently, I am pursuing MBA FSM in Sri Venkateshwara College of Engineering, Bangalore. Today, I am going to explain about the correlation relating to statistics subject. Let us know about the meaning of correlation. Meaning of correlation. Correlation is an analysis of covariation between two or more variables. Let us know about the types of correlation: positive and negative, linear and non-linear, simple, partial and multiple correlation. Positive and negative. If the value of two variables deviate in the same direction, for example, if the increase in the values of one variable results on a average in a corresponding increase in the values of the other variable, or if a decrease in the value of one variable on a average in a corresponding decrease in a value of other variable, correlation is said to be positive or direct. For example, price and supply of the commodity. On the other hand, correlation is said to be negative if the variable deviate in the opposite direction. Linear or non-linear correlation between two variables is said to be linear if corresponding to a unit change in one variable, there is constant change in the other variable over the entire range of the values. For example, y is equal to ax plus b. The relationship between two variables is said to be non-linear if corresponding to a unit change in one variable, the other variable does. Simple, partial and multiple. The distinction among these three types of correlation depends upon the number of variables involved in study. If only two variables are involved in study, then it is said to be simple correlation. Three or more variables are involved in study, then it is problem of either partial or multiple correlation. In multiple correlation, three or more variables are studied simultaneously. But in partial correlation, we consider only two variables influencing each other while the effect of other variable is held constant. For example, let us suppose that we have three variables: number of hours studied x, IQ y, marks obtained as z. If a multiple correlation, we will study the correlation between z with two variables x and y. When we study the relationship between x and z, keeping an average IQ as constant, it is said to be study involved partial correlation. Methods of correlation. There are two types of methods of correlation: graphical method and algebraic method. In graphical method, scatter diagram. In algebraic method, Carl Pearson's method, rank method and concurrent deviation method. Process of calculating coefficient of correlation. Calculate the means of the two series x and y. Take deviation in the two series from their respective means. Indicate as x and y. The deviation should be taken in each case as the value of individual item minus. The algebraic method: square the deviation in both the series and obtain the sum of the deviation squared. Columns in would give summation x square and summation y square. Take the product of the deviation, that is summation xy. This means individual deviations are to be multiplied by the corresponding deviation in the other series and then their sum is obtained. The values thus obtained in the preceding steps, summation xy, summation x square and summation y square, are to be used in the formula for correlation. Scatter diagram method. Scatter diagram is a graphical representation of bivariate data. Here, bivariate data with n pairs of values is represented by n point on the xy plane. The two variables are taken along the two axes and every pair of value in the data is represented by the point on the graph. The pattern of distribution of points on the graph can be made as for the rough estimation of degree correlation between the variables. In the scatter diagram, if the points from line with positive slope, the variable are positively and perfectly correlated. If the points from a line with negative slope, the variables are negatively or perfectly correlated. If the points cluster around a line with positive slope, the variables are positively correlated. If the points cluster around a line with negative slope, the variables are negatively correlated. If the points are spread all over the graph, the variables are non-correlated. The following points may be borne in mind in interpreting the scatter diagram regarding the correlation between two variables. If the points are very dense, very close to each other, the fairly good amount of correlation may be expected between the two variables. If the points on the scatter diagram reveal any trend, the variables are said to be correlated, and if no trend is revealed, the variables are uncorrelated. If there is an upward trend rising from lower left hand corner and going upward to the upper right hand corner, the correlation is positive, since this reveals that values of two variables are move in same direction. If all the points lie on a straight line starting from the left bottom and going upward the right top, the correlation is perfect and positive. If all the points lie on a straight line starting from left top and coming down to right button, correlation is perfect and negative. The method of scatter diagram is readily comprehensible and enable us to form a rough idea of nature of relationship between the two variables. Inspection of the graph. Moreover, this method is not affected by extreme observation, whereas all mathematical formula of ascertaining correlation between two variables are affected by extreme observations. The method of scatter diagram tells us about the nature of the relationship, whether positive or negative, whereas it is high or low. It does not provide us exact measure of extent of relationship between two variables. The scatter diagram enables us to obtain an approximate estimating line. The line is best fit for freehand method. Carl-Pearson's coefficient of correlation. This is measure of linear relationship between the two variables. It indicates the degree of correlation between the two variables denoted by R. Interpretation of coefficient or correlation. The positive value of R indicates positive correlation. Negative value of R indicates negative correlation. R is equal to plus 1 means correlation is perfect positive. R is equal to minus 1 means correlation is perfect negative. R is equal to 0 or low means the variables are non-correlated. Carl-Pearson's measures known as Pearson's correlation coefficient between two variables x and y, usually denoted by R, is a numerical measure of linear relationship between them and is defined as a ratio of the covariance between x and y, written as covariance xy to be product of standard deviation of x and y. Coefficient of determination. The strength of R is judged by coefficient of determining R square for R is equal to 0.9, R square is equal to 0.81. We multiply it by 100, thus getting 81%. This suggests that when R is 0.9, when we can say that 81% of the total variation is the Y series can be attributed to the relationship with X. Rank correlation method. Sometimes we come across statistical series in which the variable under consideration are not capable of quantitative measurements but can be arranged in a serial order. In such a situation, Carl-Pearson's coefficient of correlation cannot be used. Carl Edward Spearman, a British psychologist, developed a formula in 1904 consist in obtaining the correlation coefficient between ranks of n individuals in the two attributes under study. The Spearman's correlation coefficient between the rank x and y is called rank correlation coefficient between characteristics A and B for that group of individuals. The students are assigned ranks in statisticals according to their marks in statistics. Also, they are assigned ranks in mathematics according to their marks in mathematics. Then the correlation between these two sets of rank is called rank correlation. The coefficient of correlation computed for these ranks is called Spearman's coefficient of rank correlation. In a bivariate data, if the value of the variables are ranked in the decreasing order, the correlation between these ranks is rank correlation. The coefficient of correlation computed for this rank is Spearman's coefficient of rank correlation. It is denoted by P. If R1 and R2 are the ranks in the two characteristics and D is equal to R1 minus R2 is the difference between the ranks. Coefficient of rank correlation P is equal to 1 minus 6 summation D square divided by N3 minus N. Since P is the product moment, coefficient of correlation between the ranks, it is a value between minus 1 and plus 1. Carl-Pearson's coefficient of correlation can be calculated only if the characteristics under study are quantitative. The Spearman's coefficient of rank correlation can be calculated even if the characteristics under study are qualitative. If it is possible to align ranks to the units with regard to the two characteristics, coefficient of rank correlation can be calculated. Algebraic method. This is very casual method of determining the correlation between two series when we are not very serious about its precision. This is based on the sign of the deviation of the value of variable from its preceding value and does not take into account the exact magnitude of the values of the variable. Thus, we put the plus sign, minus sign, equal sign for the deviation if the value of the variable is greater than, lesser than, equal to the preceding value respectively. The deviation in the values of two variables are said to be concurrent. If they have the same sign, either both deviation are positive, both are negative, both are equal. The formula is used to computing correlation coefficient R. R is equal to plus or minus root plus or minus into 2c minus n divided by n, where c is the number of pairs of concurrent deviation and n is the number of pairs of deviation. In the formula, plus or minus sign is it to be taken inside and outside the square root of fundamental importance. Thank you for watching. If you like my video, do like, comment and subscribe my YouTube channel. Thank you for watching.